This is a kinematics question for Mechanics 1 at A-level mathematics, and it involves horizontal motion using the equations of motion. So let's have a look how we go about it. We've got a particle moving with a constant acceleration. It's probably the first thing to highlight really, is the fact that it's got a constant acceleration, but you should expect that from M1 anyway. And we've basically got three situations. We've got first of all, that we've got a distance of 10 meters is covered in 2 seconds, and all we know about the acceleration is it's constant. We then find out that after another 2 seconds it's gone 22 meters. If you look at this as a total, then it's gone a total of 32 meters over 4 seconds, and again that's constant. And the question's asking us that if it travelled for a further 2 seconds, how far would it get at that acceleration? So we're going to need to first of all start with this first situation here. So if we look at one, we've got S, T and A. I'm going to use U, so I can put it in the equation S equals UT plus a half AT squared, and if I do that I end up with 10 equals U times T, so 2 times U, 2U, and then half of whatever the acceleration is, and then times that by T squared. So we'll have half of T squared, half of 4, which is 2, end up with 2k, whatever my acceleration tends to be. If I do the same with the second situation, we'll end up with 32 equals 4u and then a half t squared, so half of that squared, which is 8, so we end up with plus 8k. Feel free to sort of pause it, take your time and check that you're okay with those two expressions and where they've come from. Using a bit of simultaneous equations, I think I use elimination. If I just double this equation here, I can then find the difference between them, and if I do this one here minus this one here, I end up with 12 equals 4k. That tells us that our constant acceleration is 3 meters per second, which will prove useful for working out our distance. Now it's also worth finding out what our initial speed at the beginning of the whole process was, and we can do that by plugging k back into our first equation here. So we've got 10 equals 2u plus 6, which means that u must be 2 meters per second. And then for our final situation, we can find out the total distance travelled. So S will be u times t, which will be 12 plus a half of the acceleration times t squared, which is 36, and we find out that we get S equals 12. Half of 36 will be 18, and then 18 times 3 is 54. So we've got 66 meters travelled in total. Just reminding ourselves of the question, how much further does it travel in the next 2 seconds? Well, that will be its total distance minus how far it travelled in the first 4 seconds, and we end up with 34 meters as our final answer. So it travels a further 34 meters in the next get rid of that seconds. There we go. Feel free to go and have a look at the video and repeat it. Post any comments you've got on the comments box, and hopefully I'll be able to help you out. I hope that was helpful.